everyone, welcome again. So in the previous video, I have explained what is Kruskal algorithm and how to find minimum spanning tree using Kruskal's algorithm. So here in this video, I will explain how to implement Kruskal algorithm in any programming language. So before moving, two things I will discuss actually in this video. One thing is how to detect a loop. Okay, so if a given age will form a loop or not, how to detect that thing. And then obviously the programming. So one by one I will step by step code that thing. Okay, see you next. Okay, so now we will discuss like how to detect a loop when actually one edge we are adding. Okay, so before that I have to talk about few matrices. Okay, so this one actually you already seen. So if this is the graph, so here actually I have sorted them based on their weight. So I have mentioned like from and to, though it is I have no value because to from can be interchangeable as it's a non-directed graph. Okay, so 2 to 0 the weight is 2 and then 1 to 0 the weight is 5. Like that way I have sorted them based on their weight. Okay, so now we have to take another matrix. Okay, so this is, you can give it as a name as parent rank matrix maybe. So what is parent rank matrix here? So if you notice here, so I have marked all the nodes here from 0 to 6, 0, 1, 2, 3, 4, 6, 5, 6. Okay, and initially all of their parent will be minus 1 and the rank is 0. Okay, so here actually how to detect loop, that part only I will focus more, means the steps. So actually how it is working, for that I have to make a separate video to understand how to using disjoint set we can find a loop. So there we can understand it is more, but here I will talk more about the steps. Okay, so now I have mentioned all the parent as minus 1 initially and the rank as 0. Here I took one helper matrix, you can say. In actual programming it is not needed, just for understanding purpose. What I did is, so when I will start calculation for this matrix, that time for from I will identify what is the absolute parent for it, and for 2 what is the absolute parent for this 2, and what is their corresponding ranks. So what is this absolute parent? Absolute parent means suppose the parent of 3 is 2, then 2's parent is 4 and 4's parent is 0. So then 3's absolute parent will become 0. Okay, so we have to calculate based on that. So we have to start now, then you will understand it. Okay, so first start with this edge. Okay, so I will mark it as visited because I am starting with it. So what we will do is, from is 2, I will place it here, and 2 value is 0, and I will repeat the same thing in the rank portion also for understanding better. So what I will do, first I will pick up one edge, then from and to I will place it. Okay, like this. Then I will go to the main matrix, and here I will check what is the absolute parent for this from node. So the node is 2. So for the node 2, the parent is minus 1. I will write it here. And for 0, the parent is also minus 1. Okay. And if I see their rank, then the rank of 2 is initially 0 and the rank of 0 is also 0. Okay, so the rule number 1 is, if the absolute parent for both the nodes like from and to is minus 1, then straight away we can include this node, means this node this edge will not form any loop. Okay, so I will mark it as green. That means this node we are including, this node. Now what is the purpose of rank here? So initially both of their rank is 0. Okay, so now if their rank is same, then what we can do is we can simply say from will follow 2 means you can assume that 2 is actually following 0 here. Okay, so there is an arrow mark from 2 towards 0. That means now 0's rank will be 1 more because 2 is following 0. Okay, so the rank of 0 will become plus 1. Okay, and if you see here, if 2 is following 0, that means 2's parent will become 0 now. So the 2's parent will become 0 now. Okay, now what you will do is this value I calculated here. Okay, so this matrix is just for the calculation purpose. Now I will replace these values in the main matrix. So I will go to 2's block, then the absolute parent from here I will mark it as 0, and 2's rank will be 0 only. Then what I have to change, this absolute rank of 0, so that will be 1. Okay, so the first step is done. The work for the first edge is done. Now we will delete this and then we will visit this edge. So here from and to value is 1 and 0. So we will quickly place it here, 1 and 0. So now what is the absolute parent for 1? So we will go to 1, the absolute parent is minus 1. And for 0 it is also minus 1. And rank wise 1's rank is 0 and 0's rank is 1. Okay. So now as both is minus 1, that means we can include what I told for this previous case. Okay, so this is also good to go. We can include this edge. And who is following whom? That also we can check now from the rank. So the rank of 2 is higher. That means 2 means this node 0. So 1 actually will follow 0. Okay, as 1 is following 0, that means 0's rank will be higher. So as it is already higher, we don't have to make it plus 1. Okay, so what I can do here is for 1, now as it is following 0, so 1's parent will become now 0. Okay, so I think the only change you have to do in this main matrix is 1's parent will become 0. Okay, so after this iteration, you can consider it as maybe iteration in the programming. Then it will become, the matrix will look like, the parent rank matrix will look like this: minus 1, 0, 0, minus 1, minus 1. Then it will become 1, 0, 0, 0. Okay, so let's delete it, then move to the next edge. So I will mark it as visited, then 6 and 4 I will take quickly. 6 and 4, 6 and 4. Okay, so what is the absolute parent for 6? The absolute parent for 6 is minus 1. Let me place it here. And rank also I can copy. 6 rank is 0. Then for 4, the absolute parent is minus 1 and the rank is 0. So as both of their absolute parent is minus 1 and minus 1, that means we can straight away include this edge. Okay, so we are lucky, right? Because every time we are getting minus 1, minus 1. So let me include this one. Now we have to see if we have to change this rank. Now as both of their rank is same, so what approach we will follow is from will follow 2. That means this rank will be increased to 1. And as 6 is following 4, that means 6 parent will become 4. Okay, so what change is required in the main graph? So 6 will follow 4. Okay, so 6 will follow 4 and the rank of 4 will become 1. So now delete it and come into this edge. So it is 5 and 1. So 5, 1, 5 and 1. So what is the absolute parent for 5? So it is minus 1. Place it here. The absolute parent for 1. See, now we have to understand this thing. So the parent of 1 is 0. So who is 0's parent? That is minus 1. That means the absolute parent for 1 is 0. We can place it here. Now we have to place the ranks. So when we have to place the ranks, we have to take the rank of their absolute parent. As the absolute parent for this from node or the 5 is minus 1, then you have to take this one only. But for 1, the absolute parent is 0. So what is the 0's rank? That is 1. So that one we have to take, not 1's rank. Okay. So now what we can see is their absolute parent is different, minus 1 and 0. So in this case also we can include this edge. Okay. So we can include this edge. So when we can't include the edge, so when their absolute parent will be same, but they are not minus 1. Suppose their absolute parent is 4 and here also it came as 4. Then we can't include that edge because that will form a loop. Okay. So now who will follow whom? So it is straightforward that as the rank of 2 is higher, then means 5 will follow 1, means 5 will follow 1 here. Okay. So 5 will follow 1, that is fine, but what is 1's absolute parent? So 1's absolute parent is 0. That means actually 5 will follow ultimately 0. Okay. So now we have to change these values. Okay. So 5's absolute parent will now become 0. And 1's absolute parent is 0, that is already defined. So 5's rank will be 0 only and the rank of 1. Okay. So the rank of 1 will not change here because 1's absolute parent is 0 and for that purpose it is already present here as 1. Okay. So the things to remember here, so always the change will be to the absolute parent. Okay, not that particular node. Okay. Now we have to delete this one. Okay. So 5 to 1, this is actually added. Okay. Minus 1, 0, 0, minus 1, minus 1, 0, 4, 1, 0, 0, 0, 1, 0, 0. Okay. Now we have to visit this edge. So what is the from and to? 4 and 3. 4 and 3. Okay. So what is the absolute parent for 4? The absolute parent for 4 is minus 1. And the absolute parent for 3 is also minus 1. That means we are lucky. The absolute rank of 4 is 1 and the rank of 3 is 0. Okay. So why we are taking directly this rank? Because their absolute parent is minus 1. Okay. That means he itself is the absolute parent. Okay. So if their absolute parent is minus 1, that time we will take the rank value of that node itself. Okay. So now minus 1, minus 1, 1, 0. So we have to include this. And who will go where? Who will follow whom? So as 4's rank is higher, that means 3 will follow 4. 3 will follow 4. So what will be the parent of 3 now? So the parent of 3 will become 4 now, because the absolute parent for 4 is 4 itself. Okay, so 3's parent will become now 4. So what change is required in the main matrix? That is 3's parent will become 4 now. Okay, so no other changes are required. So delete this. Now jump into the another edge. So the edge is 4, 2. So already we have identified 1, 2, 3, 4, 5 edges. Okay, so if this edge is good to go, means this edge is not forming loop, then we have to stop here, because to connect these 7 nodes we need 6 edges only. Okay, so let's check it. So 4 and 2 we will place here, 4 and 2. Okay, so the absolute parent for 4 is -1. Okay, and the absolute parent for 2 is 0. That means 0 absolute parent is -1. Okay, so nowhere to go. That means 0 will be the absolute parent for 2. So there should be maybe some cases like 2's absolute parent is 1, then we have to again come to 1 to check like if it is -1 or not. So where actually it will be -1, there we have to stop. Okay, so now we have to check the rank. So for 4 the rank will be 1. For 2 actually the absolute parent for 2 is 0, so we have to check 0's rank, that is 1. So we can check from here. So as it is -1 and 0 means both the numbers are different, both of their absolute parent is different, that means we can include this. Okay, and rank wise 4 and 2 both of their rank is same, that means if their rank is same then from will follow 2, that means this one we can now increase to 2. Okay, and from will follow 2, that means 4 will follow 2. Okay, so what is the 2's absolute parent? That is 0. That means 4 actually ultimately have to follow 0. Okay, so now we have to place it here 0, and sorry, this one will be 0 and this one will be 1, and 2, but 2 actually it will be 0, and this one will be 2 actually, because the absolute parent's rank we have to change. Okay, so this last calculation, maybe rank calculation, there is no need also, because we already got their absolute parent, they are different, and already we reached 6 nodes. But like to understanding purpose I just showed to you. Okay, so we got all the edges which are required to form a spanning tree, and for our example luckily none of them were forming any loop, but it may form a loop if their absolute parent are same but not -1. Okay, so if 3 and 3 will come here as absolute parent, that means that edge can form a loop, so we will not take that one. Okay, so we can jump into the next one, we can discard that one and jump into the next one, and that way when 6 edges will be picked up we can stop. Okay, so this is the logic behind finding a loop before selecting a edge. So now we will jump into the programming part and implement this logic along with the other part. Okay, so now coming to the programming part. So for the programming part I need two classes. One is the edge and what is the Kruskal algo. There actually I will write the main algorithm. So what is this edge class? there I have just defined from, to and weight. So if you have seen that list I was showing based on the ages, I have sorted them uh, like weight. So to represent that a single row, I have defined a class called age. Okay, so age will have from, to and weight as a parameter. And I am implementing this comparable method because I will override this compare to method. They're actually to sort it based on their weight. I have wrote this method. Okay. Now coming to the main graph part. So I have already wrote few things to make it quick. So this is the Kruskal Algo main class. So there I have defined like what will be the number of vertices of the graph, and this parent rank matrix, that will be a two-dimension matrix. So what I have shown in the previous section, and this matrix I am filling up with v number of uh, vertices, and the upper portion, the zero portion, will be the contain the parent part, and the below portion will contain the rank part. So I am initializing the parent part as -1 and the rank part as 0. Okay, and in the main method, what I am passing is one graph I am passing, and this is the adjacency matrix format. So this is the adjacency matrix format of the graph, not adjacency list. And then I am initializing this graph by passing the length of this matrix. That means actually the number of vertices I am passing. Okay, so this is the structure of the graph. Okay, and I have already shown these things in previous videos also, like how to construct a graph. Okay, so now for starting the main part, that is the Kruskal algorithm, so I have to write one method for that. Okay, so that method will be public void print Kruskal method. Okay, print MST, and what it will take is the main graph. It will take it as a input. So the main graph will be the adjacency matrix. Okay, then what I need to do is I need to sort their edges. Okay, so I need to sort their edges. So what I will do is I will create a array list here of edge, and I can give a name as list. Then I can define a method called sort the edges. Okay, so there I will transfer this adjacency matrix. So now I have to implement this method. Okay, so basically how it will look like is, I'm just simply pasting here to save some time. So what it will do is it will take the main graph as an input, then it will create the list of their edges. Okay, so because it is adjacency matrix, so to form it as like from, to, and then the edge, I have to take it like that. And if you notice here, so in adjacency matrix, if I take all their edges, then actually it will be a repetitive, because by default adjacency matrix, it is identical on their diagonal part. Okay, so that's why what I did is I am for the j counter, like the inner counter, I am taking only to the I part. Okay, so only to the till diagonal part only I am taking it, so only one half of the matrix I am taking. Okay, then there will be no chance of repeat. So you can simply go through this method. What it is doing is it is picking all the distinct edges with their weight, and it is putting inside the list. And then I am just doing a simple collection dot sort edge list, and it is returning the edge list. Okay, so before coming to the main algo part, my edge list is prepared. So what is this age list? So in this age list, I have all the ages, distinct ages. So where actually it will be from to, and the weight will be mentioned, and it is sorted based on their weight. So this is present inside this age list. Okay. Now I have to start writing the main program part. So what I can do is I can define a counter variable here that will be 0. So it will give me the count of the ages which already I have chosen for the MST. So when it will be less than 1 of the number of vertices, then I have to stop. Okay. Okay. So now what I have to do is I have to write a method which will check that a edge which is coming is forming a loop or not. Okay, so maybe we can give the name of that method as is this edge forming a loop or not. Okay, so I will simply copy and paste it here. Here. Okay, so it will simply take one edge and it will talk like this edge is forming any loop or not. So this need another method that is called get absolute parent. So that will also I will place it here. Okay. So what this method is doing is, so whatever I have just explained in the previous section in that Excel sheet by making the matrices and one by one value how it is changing, the same logic is actually logically it is written here. If you go through it, you will easily understand. Okay, so if you see like the I am calculating their absolute parent here by doing a while loop until it is -1, then I will get their absolute parent. Okay, then if their absolute parent of both of them is -1, then there is some kind of calculation is there. Okay, and if their absolute parent is equal here, if you see means if they are not -1 but still also they are equal, then I am sending true. That means is this edge forming a loop? Yes, it is forming a loop. For other cases it is not forming any loop, so that time we have to do some adjustment, right? Maybe we have to sometime increase the rank, or maybe we have to define who's parent or not. Okay, so if the rank of the from is greater than 2, then 2's parent will be the from. Okay, so like that way I have wrote this logic. You can go through it and you can easily understand it. Okay, so and this is the helper method for this method. Okay, so this part is done. Now we have to write the main part. So for that purpose, what we have to do is we have to define a while loop. Okay. So for this while loop, I have to take another counter here to check like what is the actual node selected. So we can say MST edge count, that will be 0. Okay, so this counter will take the number of edges which is already selected. So if this length whenever it is not equal to this dot v means number of vertices -1, till then we have to continue. Okay, so now what we can do is we can take the first edge here. So the edge will be edge n, and where I will get it from this list, I will get this. So this list dot get, if I do count here, then I will get that. So as count is set to 0, so we will get the first value from that list. That means the edge with the minimum weight I will get first. So this two counter, you saw the difference, right? So this counter will just simply give us the edges one by one, and this will just keep the count like who is got selected. So if some edge is got selected, then only it will increase the value to 1, and this counter will always be plus 1. Okay, so it will give us the supply of each and every edges one by one. Okay, now as I got this one, I can simply say count plus plus. Okay, because for the next time I need the position 1. So the first position, so now I am getting the 0th position edge, that is the first edge. Then next time I need the second position. Okay, so that's why I made it a counter plus plus. So now we'll check if this edge is a good fit or not for taking. So what I can check is I can simply call this method. So if this method, and I have to pass this edge, right? So this edge I have to pass. And if it is true, that means if it is forming a loop, that means that time I have to continue. I will not include this edge, I will just continue and I will check for the next one. Okay, but if it is not forming any loop, that time you can take it, right? So that time what we can do is we can just simply print that this edge got selected. So I can mention this from, then we can mention to end dot get to is selected and their weight is n dot get weight. Okay, we can print this one, and as this edge got selected, we will increase this counter's value. Okay, so this is all about the programming. So we have to run this one. Okay, let me check once. Okay, sorry, I have to call this method from here. So what I can do is I have to call this main graph dot print MST, and I have to pass this graph. Okay, now I have to run this. So you can see we are getting the result like 220, the weight is 2, that is got selected, then 1205, 6245, that way 1 2 3 4 5 6 edges got selected. Okay, so this will form the minimum spanning tree. So if you look here in the entire program, so the most difficult, or you can say the more code or understanding required, is only in this part, that is this edge forming a loop or not? So for that only purpose only I give this explanation. Apart from that, sorting the edges based on their weight, and then this part and all we already did in previous few examples or cases also. So go through this again and try to match it with the logic. Okay, then you are good to go, and this part you can implement in different way also. Okay, so this programming link I will give in the description box. Thanks for watching this.